Welcome to qnawire.
Hello students, here a firework rocket explodes at a height of 42 meter, producing fragments with different velocities, and this ranges from 9.68 meter per second downwards and to a velocity of 16.7 meter per second upwards. Now we have to calculate over what time interval are the fragments hitting the ground. That means delta t we want to calculate. So here we want to calculate the time required for this process and time required for this process, and we have to subtract these two. So first let's consider the downwards fragments. So this is downwards, and by using the kinematic equation, that is the displacement delta t is equal to ut plus half at square. In this case, the displacement is, it starts from 0 and reaches a height of 42 meter. That is 42 minus 0. Since delta d is equal to final distance minus the initial distance. Your final distance is the height it reaches, that is 42 meter, and initial distance is the 0. And u here is 9.68. So 9.68 meter per second. 9.68 into t plus half into 9.8 t square. So solve this, we get 42 is equal to 9.68 t plus 4.9 t square, and if we rearrange we get a quadratic equation, that is 4.9 t square plus 9.68 t minus 42 is equal to 0. So if we solve using the quadratic formula, that is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So using this formula we can find out x, and we get two values for x. One is 2.107. So here we are using the variable t. So therefore t is equal to 2.107 seconds, and another one is minus 4.066 seconds. Here the time should not be in negative, so let's consider this positive value. Therefore the t is 2.107 seconds. Similarly, we have to calculate the time that is required for the upwards motion of the fragment. So now for upward motion, delta d is equal to ut plus half at squared. In this case, so here the final distance will be 0 and the initial height is 42. So 0 minus 42, this is equal to u is 16.7 t plus half into a here is minus 9.8 t squared, and if we rearrange this equation we get minus 42 is equal to 16.7 t minus 4.9 t squared. Rearranging we get 4.9 t squared minus 16.7 t minus 42 is equal to 0, and if we solve this expression we get t is equal to, let this be t prime, so t prime equal to t is equal to 5.091 seconds, or another value is minus 1.683 seconds. Here we will ignore this value and take this value, therefore this t prime is equal to 5.091 seconds. Now let's calculate the time interval. So time interval delta t is equal to t prime minus t, which is 5.091 minus this value is 2.107, and this gives delta t is equal to 2.984 seconds. This is our required answer. Hope you find this video is useful. Thank you.